Another important application of optimization problems, or minimum maximum problems as we like to call them, is in the realm of business where we're generally trying to minimize our costs so that we can maximize our profit or revenue. So here's a simple example of how something like that would work. We have a theater charging $4 per ticket, and it's had a full house of 400 people nightly for performances. The manager estimates that the ticket sales would decrease by 50 people for every $1 increase in ticket cost. The higher the price the theory is, the fewer people would show up. The question is, what is the most profitable price to charge? Now you might think, well, if we're filling the theater, isn't that the best scenario we can come up with? Isn't that the way we make the most money? Well, not necessarily, as you're going to see. So let's look at what's going on in this question by using a table. Often a good way to begin. We have a bunch of different things going on here. We have the number of people that go to the show. We have the price per ticket that we charge. And those two things determine our profit or our revenue. So if we have 400 people showing up and we're charging $4 per ticket, as is the case when the house is full, if we multiply these two amounts, that's what's going to give us the amount of money we made. $4 per ticket times 400 tickets, $1,600. Now let's see what happens if we do what the managers think will happen. If we raise the price by $1, the theory is 50 fewer people will show up, only 350 people. If we multiply 350 by 5, we get a profit, an inflow, a revenue of $1,750. We made more money by having 50 people, less people show up, but to do that we had to increase the price by $1. What happens if we do that again? Let's just keep dabbling in this question. If we raise the price another $1, 50 fewer people show up. So 300 times $6 per ticket would be $1,800. We've again made more money. Let's keep going. Let's see what happens. Raise the price by $1, $7, 50 fewer people. If you multiply 250 by 7, you're getting $1,750. So we've suddenly started making a little bit less money again. And in fact, it looks as though this is our best scenario. Charging $6, having 300 people show up and making $1,800. I think you can probably see the symmetry that's happening here as well, which if I did 200 by the way and $8, that's $1,600. So we can see our notion of a quadratic function showing up in this table. Let's just explore this a little bit further by trying to find the function for this table, for this scenario. And so let's go over here. We're trying to make an equation for profit because that's what we're trying to maximize. And we're using this concept of number of people times price per ticket equaling profit. Trying to look at this maximum profit situation from an algebraic point of view. So I'm going to create the function that would generate this table. Now, there's probably lots of ways to come up with, in fact, I know there's lots of ways to come up with an equation for profit, but I'm going to do it this way. I'm going to take the premise that we have 400 people and $4 per ticket. This is kind of our base amount, and if we multiply those two things, we get that. Now, I want to cause this number of people and price per ticket to change. So if I add $1 to the price, I lose 50 people. Okay, so that generates the second scenario in my list. And if I do that multiple times, n times, I'm going to let n be the number of increases in $1 ticket price. Which would be the same thing as the number of decreases of 50 people. I'm going to use that to change my people and my price. All right, so I'm introducing the letter n equaling 0 being my base scenario. my 400 people times $4 per ticket, and every one change will increase this by 1 and decrease this by 50. So if I go to the second situation, 2 increases of $1, 1 times 2 onto the 4, and 2 decreases of 50, 50 times 2 subtracted from 400. And so I've created a function here that gives me a function for profit, this column, with respect to n, this column. The number of changes in price is my independent variable, my profit is my dependent. Let's put this function into my graphing calculator. There's the window dimensions I've chosen for my function, and when I graph that and trace along it, when n is 0, no increases in price from the base amount $4, I can see that my output value is a profit of $1,600. If we have 1 increase, there's my $1,750 in profit, represented in my table, and 2, which appears to be the maximum profit, 2 increases in price from $4 to get a price of $6 generates a profit of $1,800. So we can see that the maximum profit occurs, as we've talked about with other examples, at the vertex of the parabola. So we can see from our table and from our graph that the maximum profit occurs when n is 2 and the profit is 1,800. Let's just use our knowledge of quadratic functions algebraically to confirm that. And so what I'm going to do is I'm going to take my function, I'm going to expand it to get it into standard form. Ax squared plus bx plus c equaling 0. And now I'm going to complete the square in order to come up with the vertex. In other words, we're going to translate the function into this form. Y equals ax minus p squared plus q. And so we know how to complete the square. We focus on the 2 variable terms. We'll factor out our negative 50. And we'll create a space for numbers so that we can create a perfect square. Remember, the number that goes in the blank is half of the 4 squared, which would be 4 and negative 4. We're then going to isolate our 3 terms in the brackets, because these 3 terms are a perfect square. We're going to take out our last term, which is negative 50 times negative 4, which is 200. And we're going to factor our perfect square as n minus 2 squared. Add these 2 terms together, 1,800 equals p. And we can see from our vertex form that the vertex is 2, 1,800. N being our independent variable, the number of increases, and p being our dependent, the profit. And our algebra confirms what we saw above in the table and the graph. So therefore, 2 increases in price of $1 from 4. So remember, our price was a base price of $4 plus n. So if n is 2, therefore a price of $6, 4 plus 2, $6, will maximize our profit in this situation at $1,800.